Hello, can everyone hear me?
Yes, sir.
Okay, so problem 49, have you guys tried? Yesterday we discussed the basics of the question, the beginning part of it.
Yes, sir, I tried.
Did you get anything?
Sir, I was able to get some part, but I wasn't able to get the full thing.
Hmm. Okay. Has anyone gotten anything? Anyone else? We saw here, we have to solve this equation in positive integers. Okay. So the first thing we did was we wrote it like this: minus z cube plus 3xyz is equal to 2018. And we factorized it by using a cube plus b cube plus c cube minus 3abc formula. And c is minus z. So we get x plus 5 minus z multiplied by x minus y whole square plus y plus z whole square plus z plus x whole square is equal to 2 times 2018. This is what we have. So notice that 2018 is 2 times 2009. So this is 2 into 2 into 1009. And 1009 is a prime. You can check that. Basically, it's 2 square into 1009. That's what we are getting. Right? And we have to solve this equation in positive integers. Let's focus on these factors. X, Y, and Z are all greater than 0. They are positive integers. Right? So the second factor here, this factor here, you have to realize that it will become an even number, I think. Squares, if you think modulo 2, all the squares modulo 2, right? So you could get 1 mod 2 or 1 mod 2 or 0 mod 2. The sum of squares here, it should be even. Think about it. Yeah, let's take some cases first, like without initially saying anything. Let's take a case x plus y minus z is 1. Because the product of two integers has to be equal to this. Let's take this as 1. Then the other thing must be equal to 2 into 2018, right? Correct? Do you understand what I'm saying right now?
Yes, sir.
So in that case, what we'll have is, if this is 1, you have x minus y whole square plus y plus z whole square plus z plus x whole square is equal to 2 into 2018. And this basically means x plus y minus z is 1. So we can say that we also know this result. We also know this result, zq plus 2018. So Can we use these two results to see something? This result along with this. So what I can do is, right. In this result, I can say it is x plus y whole cube minus 3xy x plus y. That is the same thing as x cube plus y cube plus 3xyz is equal to z cube plus 2018, right? Correct? Do you understand what I am saying right now?
Yes, sir.
I am just rewriting the original condition here. And now I will use this fact, x plus y is equal to z plus 1. So I can rewrite this as z plus 1 whole cube minus 3xy z plus 1 and plus 3xyz is equal to z cube plus 2018. Right? Correct. So notice that this 3xyz will cancel this term and you will get a minus minus 3xy here and z cube will also cancel. So we will end up with 3z square plus 3z plus 1 from here minus 3xy is equal to 2018, right? Is it clear that this is coming? Are you understanding what is happening here?
Yes, sir.
So what are we getting? 3 times z square plus z minus xy is equal to 2017, right? And z and x and y are all integers. So this is an integer. So 3 times an integer is 2017, but 2017 is not divisible by 3. Which means that this is a contradiction, right? I hope everyone is understanding what I'm trying to say. From the initial condition, if I take the case x plus y minus z is 1, I'm getting a contradiction. Because 3 times something is coming equal to a number which is not divisible by 3. Right? So therefore, that means that this number cannot be 1. This cannot be 1. So now we'll take the case that it could be 2 then, right? Do you understand what I will try now? X plus y minus z could be 2, right? Because the final thing is this.
Yes.
So I will say x plus y minus z is equal to 2. And therefore, now the remaining part, x minus y whole square plus y plus z whole square plus z plus x whole square should be basically 2018 then, right? If this is 2, then the remaining part is 2018. Now here, we have to try to solve this equation in integers. So what I will say is, let's assume without loss of generality that x is greater than equal to y. And let's call x minus y to be a. Okay. And let's call y plus z to be b. We are just introducing two variables to make the equations a little easier. What is a plus b? A plus b is x plus z, right? So now look at this equation. This is looking like a square plus b square plus a plus b whole square, right? Is equal to 2018. Correct? So this becomes 2a square plus 2b square plus 2ab is 2018. So this is becoming a square plus ab plus b square is equal to 1009. I hope everybody is following, right?
Yes, sir.
This is coming now, and we have this case. Overall, this case is there. X plus y minus z is 2, and a square plus ab plus b square is 1009, and this is a prime number. We have to think of what integers a and b can satisfy this situation. Okay. Notice that first of all, there are sum of two squares, and then there is an AB product also. So now we have to do some thinking about this, because otherwise we need to get some values for A and B, some candidate answers. Only then we can solve it for X, Y, and Z. Now it's about thinking about what possible A and B can satisfy this. They are integers. Sum of squares plus AB, this term, should add up to 1009. So 1009, let's think of the squares that we have, like 30 square is 900, 31 square would be 961. A square plus B square plus AB. Okay, I'll just write some of the squares. 31 square is 961. 29 square is what? 841, I think, right? 28 square is 784. 27 square is 729. And one of the squares will be big. This number will be big because y plus z is b. This is the difference, right? So this has to be small. So some small squares also we can see. Basically, you have to guess a solution here. Only if you can guess a solution, you will get the answer. A.
Sir, I also got the same equation, but I wasn't able to solve this.
Okay. Till here you got, huh? Something like this.
Yes, sir.
We have to guess a solution. I don't see any other way right now. 7. Okay, if I use b square as 729, what will happen? What is the difference? It is 280, right? No, 380.
Yeah.
No, not 380. 280. Right?
Hmm.
280 should be a square plus 27a, right? Is there a solution for this? For a?
Right.
A square plus, it is a solution. 27a and minus 280. So
It's a solution.
you're getting what?
A minus 1, 8 plus 20.
Minus 27 plus minus 729 minus.
1.
Huh?
No. I did a mistake. That's
Plus you have 800 and 320, 11120, right? By 2. This is 1,845 1849. 1849. Okay, 1849 is a perfect square as far as I can remember. What is the square root of 1849? 40. No, 43. Yeah? 43. Right.
Yes.
43. So you're getting 43, which is very nice. Plus minus 43 by 2. So you're getting 16 by 2, 8. Right? And the other root is a negative, big negative root. Minus 35. Right? So this was the difference of x and y, and we said that x is bigger than y, so we'll assume the positive answer only, right? So we're getting A is 8 and B is 27. Obviously, this is guesswork. We have to check. We could have checked with 29 square also, but that was not coming. I guessed with this because it was 729 and 1009, and I was hoping for some nice numbers. So a little bit of guesswork is involved at this stage, which gives us the value of A is 8 and B is 27, right? And now the question is over because you have x minus y is 8 and y plus z is 27. And you also have x plus y minus z is 2, right? From these three equations, this equation, and this equation, you can find the values of x, y, and z. And if you check the answer, x, y, and z values will come out to be 15, 7, and 20. You can see this will be working out. Then you can also check the other case where the third case is x minus y plus z is equal to 4. And after that, the case would be x minus y plus z is equal to 1009 or something. You have to check all these cases. There will be one more solution for it. The other solution is just a permutation, 7, 15, and 20. So it is a little bit of a tricky one, but at least one solution I hope everyone has understood how we got. Right?
Yes.
We started by taking cases of x minus y plus z. We said that when it was 1, we didn't get any solution because there was a contradiction. When it is 2, we got a solution after a little bit of guesswork. And you have to check other cases also. Okay, let's move on to problem 50. That was the trigonometry problem that I had shared. So let AB belong to 0 to pi by 2 such that you have 169 sine A sine B plus 559 sine of A plus B plus 1849. By the way, 1849 is 43 square. So we should be using that somehow. Is equal to 2018. And we have to find out the value of tan A tan B. So has anybody gotten anything here? Did anyone try the question? This is a very nice problem. It combines trigonometry knowledge with algebra. So I hope you guys have tried it. Has anybody made any attempts? Please say something.
Sir, I had a lag. So, I made an attempt in this question.
Hmm.
So 364 sine A sine B plus 1204 cos A cos B is equal to 1009. It came, but I wasn't able to solve afterwards.
What is your first step? What did you try to do here?
I tried to open sin A plus B.
Okay, but you cannot combine it with anything, no? Like if you open sin A plus B, you will get sin A cos B plus cos A sin B, right?
Yes. Oh, I made it.
You cannot combine it, no?
Huh.
So opening is fine, but after that you cannot add an all, right?
Yes, Max. Yes.
Okay. So notice what is special about these numbers. Why would somebody give numbers like this? What is special about these numbers? That everyone should be able to figure this out. It is a perfect square, no? 13 square. And what is this? We just now saw this is 43 square, right? And can you see that 43 into 13 is this? Is everyone understanding that the numbers are actually making sense?
Yes, sir.
This is a classic situation where you do middle term factors, like in algebra. If I take this term and this term, I will take 13 sin A common, right? I hope everyone is understanding that this is middle term factorization, which everybody has learned in class 8 or 9. Basically, I will take the first two terms. I will take 13 sin A common. I will get 13 sin B plus 43 cos B. And in the next two terms, I will take 43 cos A common. What will I get? 13 sin B plus 43 cos A plus 43 cos B. So basically, the left hand side is becoming 13 sin A plus 43 cos A multiplied by 13 sin B plus 43 cos B. And the whole thing is equal to 2018. Does everyone understand what we have done so far?
Yes, sir.
Yes.
Now think about the question. Now what will you do? You have to find out tan A, tan B. I have done the initial part of it. Now think about it. What can you do here? One important thing to notice here is 43 square plus 13 square. What is that? That is 2018. So that is why these numbers were chosen. There is a point to all of this. There is a reason why the question has been designed with these numbers. Okay, I'll tell you what to do. We will look at an expression like this, 13 sin x plus 43 cos x. By Cauchy's inequality, we will say that this is less than equal to root over 13 square plus 43 square times root over sine square x plus cos square x, right? I hope everyone is understanding that you're getting 13 sine x plus 43 cos x is less than equal to root 2018. This is coming by Cauchy's inequality. And basically, you have to do this inequality 2 times. You will get 13 sine A plus 43 cos B is less, sine A plus cos A is less than equal to root 2018. And you also get 13 sine B plus 43 cos B is less than equal to root 2018. And the product of this, therefore, should be less than equal to 2018. The product of this is this expression LHS. By 2 times applying Cauchy's inequality, we are getting LHS is less than equal to 2018. But the question is asking us to solve the equality case. So if the equality has to be true, then both the times we applied Cauchy, it should be equal both the times, right? I hope everyone is understanding what I'm saying. There should be equality in both cases of the Cauchy's inequality, right? Then only you will get an equation where LHS will be equal to 2018.
Yes, sir.
And in Cauchy's inequality, if there is an equality case happening, then there is a proportionality between the two vectors. For example, when I'm applying Cauchy here, my vectors are like 13i plus 43j, and the other vector is sin xi and for cos xj, right? These are the two vectors on the basis of which I was applying this. And there is a proportionality of both the vectors must be parallel for equality case. So you can say sin x by 13 should be equal to cos x by 43 for equality. If you don't understand this, you have to go back to the previous videos where I was explaining the Cauchy's thing and when equality happens. And this has to be true for both x is equal to a and x is equal to b. So you have sine a by 13 is equal to cos a by 43. And also sine b by 13 is equal to cos b by 43. And from here, we are easily getting tan A is 13 by 43 and tan B is also 13 by 43. And the product of tan A tan B is 13 by 43 square. So actually, the question is an algebra problem. It's not trigonometry. The main thing is to simplify the trigonometric parts and factorize it into this form. And then think about the maximum value of both of these expressions. Both of these expressions, maximum value is root 2018. If you forget about Cauchy's inequality also, you should realize that the maximum value of these expressions is this. So both must become maximum at the same time. Only then will you have equal to 2018. And for this to be equal to this, tan A must be 13 by 43. You can check that out. I hope everyone is understanding what I'm saying.
Yes, sir.
Okay, then we'll move on then. Problem 51. Problem 51 is write 2018 to the power 2019 plus 2018 as the sum of two perfect squares. You have to write it as a sum of two perfect squares. And remember, we can always use the fact that 2018 is 43 square plus 13 square. We have just found that out, so we can use that. You can write 2018 to the power 2019 plus 2018 as 2018 into 2018 to the power 2018 plus 2018, right? I hope that is obvious. And then we can take 2018 common, and inside you have this, correct? Now you can write this as 43 square plus 13 square. And the rest of the stuff here, I can write it as 2018 to the power 1009 whole square plus 1 square. Does everyone understand the steps so far, what we have done?
Yes, sir.
We took a 2018 common because 2018 can be written as sum of two squares. And the inside terms, I wrote it as sum of two squares again, right? Now you will see why we are doing that. We can say it is a square plus b square times c square plus d square. And I have explained this before. This is called a Lagrange's identity. This can be written as AC minus BD whole square plus AD plus BC whole square. A square plus B square times C square plus D square is equal to this. Everybody can check this. It's very obvious. What is my ABCD? A is 43, B is 13, C is 2018 to the power 1009, and D is 1. Do you think now using Lagrange's identity, now it will come as sum of two squares? Is everyone understanding what I'm saying, right?
Yes.
We are able to do this because we got the whole expression as a product of two terms, and each term was itself sum of two squares, right? And then this identity should be known to everyone. This identity helps us express a square plus b square times c square plus d square as the sum of two squares. So now all you have to do is combine AC and BD and all, and you say 43 times 2018 to the power 1009 minus 13 is my first integer square, plus the second integer is 43 plus 13 into 2018 power 1009. That's my second integer square. This square plus this square will be equal to this, which you cannot discover by any other method. This is the only way to do this. I hope you appreciate that this is weird, like how we got this. Please make a note about Lagrange's identity and see how we have applied it in this problem. How to express this random number as a sum of two perfect squares. Okay, I will move on. Problem 52. This one is on a circle with diameter AB is equal to square root of 2018. Take a point C such that AC minus BC is equal to 30. Then on the circle of diameter BC, take a point D such that BD minus CD is equal to 7. You have to find length of CD. Okay, this is the problem. Think about it. From the initial figure, just with this much, you should be able to find the length of BC.
Sir, 5.
Length of BC. Length of BC is not 5. Think about it again. You made some mistake somewhere. Everyone should realize that ACB is a right angle triangle, right? Why? Because AB is the diameter on the circle, no? So from here, by Pythagoras theorem,
BC is 43.
BC is not 43. you are making some silly mistakes now. We are getting AB square plus BC square. No, we are getting AC square plus BC square is equal to AB square, which is equal to 2018. So basically we have AC square plus BC square is 2018 and we have AC minus BC is 30. So if I do AC minus BC whole square, that is 900. And I can use the fact that AC plus BC whole square plus AC minus BC whole square should be 2 times AC square plus BC square. This is a standard identity, right? I hope everyone is understanding what I'm saying.
Yes, sir.
So AC minus BC square is 900. This part is known and this part is also known because AC square plus BC square is 2018. So this is 4036. So 4036 minus 900. So that will be basically 3136, right? Correct? So we are getting AC plus BC whole square is equal to 3136, right? So I think this is 56, right? 56 square should be 3136, I think.
Yes, sir.
We are getting AC plus BC is 56 from here. And we already had AC minus BC is 30. So AC is 43. You have made some silly mistake, Aradhya.
Yes.
BC is what? BC is 13, no? Correct?
Yes.
And now, once we have found BC, the process has to be repeated one more time. No, diameter is BC now, right? The same process, exactly same situation is there. With diameter BC, draw a different circle with BC as diameter and find a point D such that BD minus CD is 7, right?
Yes.
So do the same thing that we just now did, but do it one more time with a new diameter and find the answer for CD. Length of CD. But don't make any careless mistakes now.
Sir, 2.5.
Length of CD. Again, some small mistake you're making again. Just check everything once more. BC is 13, the diameter. The answer is similar to 2.5. It's not 2.5 though. CD.
So 11.5.
No. Why is this so very difficult for you guys? I don't know how you guys are making mistakes here. Just draw a new figure with diameter being BC, and there is a right angle triangle again. This is my D. BD minus CD is 7. What else do we know? We know BD square plus CD square will be equal to BC square, which is 169. Now we will take advantage of BD plus CD whole square plus BD minus CD whole square should be twice of BD square plus CD square. And we know BD minus CD whole square is 49. And this is 2 times 169, which is 338. So obviously, you get BD plus CD whole square is equal to 338 minus 49. So it is 289. So BD plus CD is 17. And if BD plus CD is 17 and BD minus CD is 7, obviously 2BD is 12 and CD is 5. The answer is 5. How are you guys getting it wrong? Is everyone clear on what we are doing?
Yes.
Yes, sir.
Both the times we are doing the same thing only. No, nothing weird is happening. It's just solving some equations using Pythagoras theorem and this condition. I hope it is clear now.
Yes, sir.
Problem 53. Let A, B, C be positive reals such that root A plus 9 root B plus 44 root C is equal to square root of 2018 A plus B plus C. You have to evaluate B plus C by A. Okay. These are the next 3 problems. You need to try all 3 by next class. Make sure that you attempt it. If nobody has attempted the questions, we will not be doing the class tomorrow. So until you attempt it yourself, I will not be sharing the solutions. So I need to see you guys also trying. Okay. So these 3 problems, make sure you try. That's all for today. We'll discuss in the next class now. Okay. Write down the problems or you can see it on the video. The video will be live soon. Write down the problems otherwise. Okay, hopefully everyone has written down the question. I'll discuss the solutions tomorrow then.
Good evening, sir.
Mm.